Hello class, and welcome to another class with Professor Choi. Today we're going to be learning how to do measures of central tendency and measures of spread of data. This is usually one of those sort of like beginning chapters in Intro to Statistics class or something of that sort. Alright, first thing we need to explain is that every time you collect a data set, there are two basic measures that a lot of us like to basically use in order to figure out where's the center of the data and where's the spread of the data. So the center of the data basically tells you where is the center located. So if you were to kind of like put all the data points in a sort of a line, then the measure of the center of the data will give you a bit of an idea of where the center of the data is. Now there are multiple ways of kind of thinking about the center of the data, so believe it or not, it's not just one, which is the one most people think about, which is the average. Now the average uses each number as a sort of weight, and that will be a good thing if the weight is important. But some of the times the weight is not important, and you might want to release the data using something different. Now to understand the difference between those two, let's just think about the difference between a mean and a median. Okay? So the mean is when each of the number is a weighted number, and then you use the weights for each number and divide it by the amount of numbers that you have. But the median is the number that's smack in the center of the data when you line them left to right and just pick the number in the middle. Income is one of those data points that the median is actually a better measure of the center of the data than the average, because income is highly unequally distributed in a lot of places in the world, including the United States. So let's come up with a basic example for this so you understand why sometimes the median is a better number than the mean. Now imagine that we have 5 people. So one person with an income of 10,000, another person with an income of 10,000, another person with an income of 10,000, another person with an income of 10,000, but then we have one person with an income of 100,000. Alright? Now we were calculating the mean, and I'm going to go over that in a little bit. What we need to do is we take all the numbers and divide it by the amount of numbers. So we basically have to do 10,000 plus 10,000 plus 10,000, and you do that 5 times, and then you add 100,000 to it, and you divide by the number of people that you have. So you got 1, 2, 3, 4, 5 numbers, and that's how you calculate your mean. Alright? Now if we were to do that particular mean, alright, looking for my calculator. Alright, we're going to have 140,000, and we're going to divide that number by 5 pieces of point, so we got an average of 28,000. That's our mean, or what most people call the average. Notice that the average doesn't represent absolutely anyone. It doesn't represent that person, and it doesn't represent any of those 4. So the average in this case does not represent the majority of the people in the data. Therefore, it is not a very valid number. I mean, it is an average, don't get me wrong. You know, it's like you could say, well, that's the average of that, but it doesn't represent most people, and therefore it is a misleading average. Alright, let's do the median instead. Now the median, what it basically is you list all the numbers from smallest to largest, or largest to smallest, and then you pick the number smack in the middle, and that's your median. So in this case, we already have it lined up. I'm just going to move this one down so we're consistent with what most books say, which is basically is listed from smallest to largest. And then the median is just a number in the middle. So we have 5 pieces of data, 1, 2, 3, 4, 5. The number in the middle is 10, and that's our median. Alright, notice that the median now represents 4 people on the data set. And therefore, the median is a better representation of our data set, if you want to tell people who's the people in the middle, than the average. Because when you have such unequal income distribution, like in this case, 4 people with 10,000, 1 person with 100,000. And notice, by the way, that those don't seem like very far away, but this is 10 times more than that one. All right? So in this case, notice that this number, which is a median, is a better representation than the mean of where the center of the data is for most people. Now, the point of today is really to learn how to calculate a lot of these. But I wanted to start with an explanation of why do we have so many measures of central tendency. It's because, again, not all measures of central tendency will be the best at any particular point in time. All right? Okay, so we're going to have to use multiple examples, by the way, because some of the specific types here are not something that you would need to use a particular data set for. So we're going to start with the simplest stuff, and we're going to move on to like the more specific sort of examples that we use instead. Okay? So we're going to start with just mean, median, mode, range, and we can probably calculate variance and standard deviation for this piece of data here, maybe mean deviation as well. But mean and geometric mean, we got to use it differently. Okay? So let's start by calculating the mean with the data set that we have. The following are students' grades in a particular class. So we got 86, 90, 65, 78, 98, and 65. Now, when you're calculating a lot of these, you're going to start getting formulas. So when you're following the formula, you're going to start getting a formula for population, or you're going to go a formula for a sample. When this is being done in an intro class, normally the professor will kind of guide you towards this is a sample or this is a population. In other words, the problem being explained to you somewhere will give you a hint of whether you need to be using the population formula or you need to be using a sample formula. And that is usually my case, especially on my intro classes. Okay? So I would sort of explain, I will guide and say, well, this is a sample or this is a population. Now, in this particular case, when I wrote it down, I was being vague on purpose to, again, try to explain that. So, in the case of a test, it will normally say the following are all grades, or are students all grades in a class, which basically means that's absolutely everyone, therefore, it's population. If I say something like, the following are a sample of grades in the class, then that's how you know that this is sample data. Okay? So, in this case, we're just going to do population. Good? Because we define this as basically being everyone in my class. Therefore, when you're going to follow the formulas for mean, median, mode, etc., you follow the population formula. Now, normally for the simple sort of calculations, they don't make any difference. But when you start getting a little bit more advanced and do other things, then it starts making a difference of whether you're doing population or you're doing sample. Alright, so in our particular example right now, we're just going to do population because I said the following are students, all grades in a particular class. So that is everyone. Okay? So this right here is a population. Now the next thing that we need to do is we need to count our population size in this case. So our n. The n is just the number of people. So we have 1, 2, 3, 4, 5, 6 students. So it's a small class. Alright, now to calculate the mean, if you're in one of my classes, I normally provide a formula sheet, and the formula sheet is posted online. If you are not in one of my classes and you're basically just learning this, understand that these formulas are available absolutely everywhere. So you just gotta, Google population mean and there'll be a formula for that. I'm gonna write it down every time I do it just so that you visualize, okay? So the population mean formula is mu equals to summation of x over n. Now the n is gonna be my population size. The x's are gonna be all of these. And my mu is basically my mean. So we use the letter mu for mean if it's population. If it was a sample, then the formula will be x bar equals summation of x over n. And the biggest difference is that this is just the formula for sample and this is the formula for population, but the formula itself is very much the same. We're going to add the data set and we're going to divide it by n, which is the total number in the data set. Usually we use Greek letters for population and parameters, and we use regular letters with some kind of sign on it for samples or statistics. Alright, so let's calculate our population mean. So mu, in this case, is going to be equal to summation of x. So we got to add all of our x's, got to do 86 plus 90 plus 65 plus 78 plus 98 plus 65. Alright, 1, 2, 3, 4, 5, 6 pieces of data. We're going to divide it by n, which is equal to 6. And that gives us our mean. Alright. I like to do, by the way, a lot of this stuff on the fly, keeps my brain fresh. So I don't like using examples that I already know the answer. So here we go. 86 plus 90 plus 65 plus 78 plus 98 plus 65. And we're going to divide that by 6. So the number that we got is 80.33. Alright? And that is our mean right now. Alright. I'm going to write my mean right here, because we're going to need that in order to calculate especially my mean deviation and my variance and my standard deviation. Alright, let's go for the median now. To calculate the median on any data set, what you have to basically do is you take the numbers and you arrange them from smallest to largest first. So in this case, we're going to do 65, we got another 65, then we got 78, we got 86, we got 90, and we got 98. Alright, now here's where it gets easier or slightly complicated. If your data set is odd, and imagine that I didn't have this 98, then the answer for your median is simple. You just pick the number in the middle, which is 78, and that will be your answer. But in this case, our data set is not odd numbers, it's an even number. Therefore, what we need to do in order to find our median is we take the two numbers in the center and we find the average between those two, and that's our median. Okay? So we got to do 86 plus 78, divide that by 2, and that's going to be our median. That's 82. Alright? Alright, now, our next measure of central location is what we call the mode. The mode is just the number that repeats the most. In some data sets, you don't have any numbers that repeat a lot. In some data sets, some numbers repeat a lot. In this particular case, the number that repeats the most is 65, so that's our mode. Alright, so 65 repeats the most, and therefore that is our mode. Okay, so again, the mode is just the number that repeats the most, the one with the highest frequency. Alright, cool, so we got all of that. Now let's do our range. Range is basically just the highest value on the data set minus the lowest value on the data set. So our range is just the highest value on the data set, which in this case is 90, minus the lowest value on the data set, which in this case is 65. And that is 25. So that is our range. Alright, hope you're following me so far. Now, we got to start going into slightly more complicated things. We have to build a little table for that. That's for mean deviation, variance, and standard deviation. Okay. Now, for our mean deviation formula, we got to do summation absolute value x minus x bar divided by n. That's our formula for mean deviation. Alright, we also have a formula for variance that has a piece of that behavior, and then it kind of goes on in a sort of different tangent at some point. So the formula for variance, if you're doing population, is summation x minus mu square over n. And then the formula for standard deviation for population is sigma equals summation, sorry, forgot the square root, so square root summation x minus mu square over n. Sorry, that's capital N because it's population. Okay? So this is my formula for standard deviation for population. This is my formula for variance for population. And this is my formula for mean deviation. Let's just start with mean deviation for now. Okay? Alright. Now, as I mentioned before, if we were doing sample, our mean will be called x bar. So when we're doing our mean deviation now, let's just assume that this is going to be our x bar for now. And again, that's just because this is the sample that we have, so it's easier to just do it with that. Alright, now let's kind of follow this formula, see where it leads us. So, we got to do x minus x bar. Every time you're solving these formulas, it's better to kind of start on the inside at the top, and then move your way out, and then go into the denominator. So, we're going to do that. The first thing we need to do is we got to have a list of our x's. Our x's are just these numbers. I like to list them because it keeps things easy. And you can follow my steps when you're doing that. Alright, next number is 86. Next number is 90. And 98. Oh wow, I just realized something, by the way. I don't know if you noticed that, but we need to go back and recalculate our range because we got it wrong. Our highest number in that data set is 98. And we're doing this on the fly. This is good. Alright, by the way, so notice that we were calculating our range before. We had to do the highest value minus the lowest value in our data set. So our range is the highest value minus the lowest value in our data set. The highest value is 98 and the lowest value is 65. So when we do 98 minus 65, we get 33. And there you go. That's our actual range. I just noticed right now. Well, this is what happens when you do things on the fly. Alright, so let's work on the next one. So the next point when we're doing our mean deviation now is we got to do x minus x bar. The x bar is the one that we already calculated here. That's our mean, 80.33. Okay? So we got to do x minus x bar. So we got to take each one of our x's and we're going to subtract the x bar that we have here, which is 80.33. So we're going to go 65 minus 80.33. That gives us negative 15.33. This one's going to be the same. All right. Then we got to do 78 minus 8.33. 80.33. All right, then we got to do 86 minus 80.33. Then we got to do 90 minus 80.33. Then we got to do 98 minus 80.33. All right, now what we have here is basically this calculation here in the formula. All right, it says s minus x bar, so we took each one of our x's and we subtracted our x bar, which is our mean. All right, once we have these, the next portion of the formula says absolute value. So we're going to do absolute value x minus x bar. All right, now the absolute value, remember, of any number is basically the positive of that number. So the absolute value is the distance between 0 and whatever that number is on the number line, right or left. So therefore, the absolute value is the positive of any value, because it's kind of like the distance between 0 and where that number is. So if it's a negative number, we're just going to turn it into a positive number. And if it's a positive number, we're just going to keep it. All right? And that's going to be our absolute value there. The next portion of the formula says we got to do summation of that. Summation. Summation basically is adding up all of those. I like to just put the summation down here because all I'm doing is I'm adding those. So I got to add them. All right, I got 66. All right. By the way, let me double check. All right, 66. There you go. All right, so that 66 is the solution for the numerator on our mean deviation. So this is 66. Now we got to take that number and divide it by our n, and our n is 6 because we have 6 pieces of data. And 66 divided by 6 is 11. Okay? So we got our mean deviation equal to 11. Alright, hope you're following me so far. Again, the mean deviation is a metric of the spread of the data. We got 11. The next one that we're going to do right now is the variance. Alright, if you're watching this video again, we're about to move to the variance. So we did our mean deviation. We're doing population variance. Alright, again, let's look at the formula for our population variance. Formula for population variance is sigma square equals summation x minus mu square over n. Alright, notice by the way that these formulas are a little complicated, so we want to go step by step, really nice and slow. So let's do that. Alright, notice that our mu is basically the same as our x bar, because remember the example that we have was population. So we don't have to do much for some of those. I'm going to rewrite it just for the purpose of making sure that everybody's following what we're doing. Alright? So right now, we're going to take the same data set and we're going to find our population variance. Okay, now, for our population variance, we need to follow this formula that says it's going to be summation of x minus mu squared over n. I like to write everything down nice and slow, so when you're following me, you don't get too lost. So, these are our x's. That's the data set that we have. And we now have to subtract our mu. So we got to do x minus mu. Now remember, the mu was this number that we have here. Okay? So we got to do this minus that. So you got to take your calculator, and for each one of these, you got to subtract 80.33. Okay, so 15.33, 15.33. Again, I'm doing it again for redundancy purposes, so people understand where I got the numbers. Alright, so 5.67, 9.67, and 17.67. Alright, so in following the formula, we're doing x minus mu. That's what this is right here. Now the next step on the formula says do x minus mu squared. So we're going to take these and we're going to square them. Now remember, every time you square a negative number, it turns into a positive number because you're multiplying negative 15.33 times negative 15.33. So we got 235.009. Alright, one of the things that I always recommend my students, by the way, at this point, is you start carrying a lot of decimal spots. It's usually better to carry at least 3 or 4 decimal spots. So you know what? Let me carry an extra decimal spot. Let's do 4. I know it's going to be a little tedious, but this is going to be really good because when you're doing homework problems, usually on online homework places or something like that, the program may be very, very specific. And if you put the decimal spot just a little bit lower, a little bit higher, you may get it wrong. But in reality, you did the whole math correctly. It's just that the program wants specific answer with a specific decimal spot and you don't have it. So the more decimal spots you carry on a lot of these, the better it is for you, because at the end, the answer, when you round it, you get the right answer. Alright, so let's carry 4 decimal spots, even though it takes more time to do. Alright, so now we're going to do this number again, square. X minus mu square, which is this number, square. Alright, then we got to do 2.33 squared, or negative 2.33 squared. Okay, then we got to do 5.67 squared. Then we got to do 9.67 squared. And then we got to do 17.67 squared. Again, I'm carrying a lot of decimal spots here, and it's just to make sure that we get our numbers right when we're going to put it on our calculator, on our program online later, with all the decimal spots. Okay, so we did x minus mu squared. You get it there, about x minus mu squared. Then we're going to add, that's the next point on the formula, it says summation. So what I like to do is I just put the summation down here, and then now we got to add all of those numbers. Alright, now bear with me on this one, because it could be a while. All right, I did all that, got 913.3334. All right, now that 913.3334, it's the number that goes at the top, or in the numerator in this formula. So we got 913.3334. Now we got to take that number and divide it by n. And n, remember, is 6. That's how many points we got in our data set. So that number divided by 6 is 152.22. So our variance is 152.22. All right? That's what we got right now for our variance. Okay, hope you're following. All right, so we got our variance of 152.22 for our data set. Now, let's work on our standard deviation. Now, here's the good news about the standard deviation. If you look at the formula for standard deviation, it's basically summation, square root, it's a sigma equals square root of x minus mu square over n. So what that's basically saying is that your standard deviation is your square root of your variance. So all you got to do is you take your variance and you square root it in order to get your standard deviation. So we're just going to take the answer that we got over here, our 152.22, and we find the square root of that. So our standard deviation is equal to square root of 152.22. And we got 12.3378. And that's our standard deviation. 12.3378. All right, so we got our standard deviation, we got our variance, we got our mean deviation, we found our range, which again I apologize, I calculated wrong at the beginning, so I fixed it. We got our mean, median, and mode. Woo! Man, I need some coffee. Oh, wait. Oh yeah, you're right, I'm missing the weighted mean, and I'm missing the geometric mean. Yeah, we'll do that some other day. No, I'm joking. We'll do it. Let's do it right now. All right, so let's get rid of this right here. Now, in order to calculate these, our weighted mean and our geometric mean, we need to come up with different examples. So the data set that we had before is no longer going to be useful. So I'm going to take that off. Okay? And now I'm going to try to calculate our weighted mean. So now we're going to be doing these right here. And again, these are with a different data set because we need a different sort of example. All right, now what is the purpose of something like a weighted mean? Now let's say that you have numbers on a data set that repeat multiple times. Do you really have to add them all the time? Let's think about this. So let's say we have an employer. Now out of the people that work in that place, 20 people get paid $15 an hour. Then we have 10 people get paid $17 an hour. And we have 4 people that get paid $22 an hour. Alright? Now if we were going to calculate the mean of this, then we would have to write down 20 times 15, then we'll have to write down 10 times 17, and we'll have to write down 4 times 22. Add all that stuff. Then divide it by the amount of people. That's a bit of a waste of time because there's just a faster way to do it, and that's really the point of the weighted mean. Okay? So in this particular case, what we're going to do is we're going to calculate the weighted mean. Now the formula for the weighted mean is x bar w equals first weight times the first x, and then you do that all the way to the last wage, last x, and then you divide that by all the weights. Alright, now for us in here, this is going to be 20 people, $15 an hour. So we got to do 20 people, $15 an hour. Then we got to add 10 people at $17 an hour. And then we got to add 4 people at $22 an hour. Notice that in this case we're trying to calculate what is the average wage. Now if we were doing it the way we did it before, through the regular mean, we would have to write down 20 times 15, because we will have to write down 15, 15, 15, 15, 15, 15, 15, do that 20 times. Then we will have to write down 17 10 times and 22 4 times. Here we're kind of shorting it, and that's exactly what we're getting here. Then we're going to divide it by all the weights, which is 20 plus 10 plus 4, because 22 is there 4 times, so the weight is 4. Alright, so let's do this. If you're going to plug in all of that, by the way, in your calculator, make sure that you do lots and lots of brackets. Don't miss any brackets. So we got to do 20 times 15. Then we got to add 10 times 17. And then we got to add 4 times 22. We got 558, that's what I got at the top. And we got to divide that by 20 plus 10 plus 4. And I got 164118. So my average wage in this business, it's about 1641. That's the average wage using the weighted mean. Good so far? Alright. Let's find some uses for a geometric mean. I know, by the way, that some of you watching may be a bit overwhelmed with the data that we have, but remember, it's a video, you know, it's like move back, move forward, stop it so you can write down the data. The best way to really study this, by the way, is to kind of like practice as I'm doing it. So in other words, write down the data, kind of like take some notes and kind of like try to do it on your own. And then the best way really is to just practice on your own. Alright, so let's take a look at the next one. We're going to do the geometric mean. Alright, now the geometric mean is going to be equal to the nth root of multiplication of x's So let's come up with an example of how this one is useful. As you probably know, when somebody says something increased by 10% or something increased by 20%, the 20%, it's really a number on the top of the previous numbers. If I say I grew by 10%, and I'm taking this number, and then the growth was 20% from that number, but then now you have a different base, and then when you say I grew by 20% again, then the other number is going to be greater than the previous 20% because it's going to be on a greater base. So that's what you use this for. Now, let's come up with an example for that. So let's say my salary increased on year 1 by 10%, year 2 by 5%, year 3, let's say that it went down by, let's call it a 4%, and then year 4, it went up by 10% again. The question is, what is my average salary change or salary increase in the last 4 years? Mean or average increase in salary over the last 4 years. Okay, now to do this one, the first thing that we need to do is we need to put the numbers and take those numbers and put them into decimals. Okay, so I'm going to take this number, 10%, and I'm going to write that number into a decimal. In order to write a percent into a decimal, we got to take that 10% and we got to move this point 2 to the left. So it becomes 0.10. So this number in decimals is 0.10. Alright, now 5% in decimals is going to be 0.05, and 4% in decimals is going to be 0.04. Now notice, by the way, that this one is down 4%, so it's -4, so that's negative 0.04. Okay? Then this 10 is 0.10. Alright, I don't know if you're good at math or not, but negative numbers don't play very well here. So in order to kind of get rid of that, the next step is we got to add the number 1 to these numbers here. So we just add +1. We're going to take that 1 later, okay? So we'll take it later, but for now we're going to add it so that every single number that we write here is going to be basically a positive number. So we're going to turn this into a 1.10. We're going to turn this into a 1.05. We're going to turn this into, okay, 0.96. And we're going to turn this into a 1.10. Again, what we did is we added 1. So if you take 1 and you add it to -0.04, it will end up with 0.96. Alright, now we can plug in those into the formula. Notice that our n is equal to 4 because we got 4 pieces of data. So our geometric mean is equal to the 4th root of all of those numbers multiplied. Okay, so we're going to put 1.10 multiplied times 1.05 multiplied times 0.96 multiplied times 1.10. And and we're going to do the fourth root of that. Alright, you know what? I'm going to do it in 2 steps. Yeah, better. So let's do 1.10 times 1.05 times 0.96 times 1.10. Alright, so in here I have 4th root of 1.2197. Remember, we're carrying 4 decimal spots here. And then we'll take the 4th root of that. Okay, 1.2197. All right, so we got 1.0509, but we're doing 4 decimal spots. Got it. So here we go. And that is my geometric mean. Now, remember, in order to get all those numbers, we added a 1. So now we just got to subtract that 1, and we got our geometric mean. So our geometric mean for this so in order to get these numbers, we added a 1. Now we just got to take that 1 away, and we got our geometric mean. So we take the 1.0509, we take away 1, and we end up with 0.0509. Now remember, that number is also in decimals because we took those numbers and made them decimals. So if somebody asks you, what was your average increase in salary during that time period, what you're going to say is you're going to say 5.09%. And that will be your answer for the average salary increase in those 4 years. So the average salary increase was 5%. All right, I hope you like that example. It's kind of long. All right, let's take a look at another way in which we can use our geometric mean. Let's call it geometric mean 2. By the way, right now I was just having flashbacks of when I'm in class. Of course, right now we're not in class because of I'm teaching you online. But normally when I'm in class and I'm running to like erase the board, somebody goes, wait. Well, the good news is you don't have to do that right now. Again, this is a video. So remember, you can just move back a little, freeze it, and you can see the numbers. All right, so in any case, let's take a look now at the second geometric mean. All right, so this is a geometric mean of rate increases. Okay, so we're going to do a geometric mean is equal to the nth root of value at the end of the period divided by value at beginning of the period minus 1. Alright, now what do we use this one for? Okay, so let's say, for example, say the population of Choitopia has increased in the last 20 years from 1 million people to 1.9 million people. And the question is, what is the average rate of growth of that population? So what is the average or mean rate of growth? And again, per year. That's what we're looking for here. It's kind of like your wage. When we said 5%, it was 5% a year. Okay, so in order to solve this problem, all we need to do is we got to find the value at the end, value at the beginning, our n, and we got to take the square root of that, the nth root of that, and subtract minus 1. So the n period is 1.9 million. So we're going to do nth root of 1.9 million. There you go. We're going to divide that by the beginning period, which is 1 million. Alright, now the nth is going to be the 20 years. Because it's 20 years, the population has changed by that. And then when we're done with that, we're going to do minus 1. And that's going to be our geometric mean. Okay? So, let's plug that into our trustworthy calculator. Okay, close that up, enter. Okay, so I got right now, for this portion here, I got 1.0326. Now we got to subtract 1 to that, and we get 0.0326. Now that number that we have is in decimals, right? We need to transform that number into percents. So this becomes 3.2%. So this becomes 3.26% growth. And that is our answer for what is the average or mean rate of growth in the country of Choitopia for the last 20 years. 3.26% growth in population per year. All right. That was a long one, but I enjoyed it. How about you? So remember, what we did today is we went over numerical measures of central tendency and the spread of the data. We calculated our mean, our median, our mode, our range, which I did wrong at the beginning, they corrected. We did our mean deviation, our variance, our standard deviation. We calculated a weighted mean, and we did a couple of geometric means. I hope you like this lesson by Professor Choi and you keep tuning into my channel because I got more stuff for you. Thank you very much.